Welcome back everybody to Nick Does Maths with me, Nick, and some maths and a whiteboard and a microphone and a pen. Did I miss anyone? And you there. Right, we're going to play around with some functions and some combinations of functions and functions of functions and functions and functions. We got two functions, f of x is x plus 1, g of x is 2x. Two cracking little functions right there. So just to make sure we understand, f to the power of I of x just means f of f of f of f of f of x. All right, we've got these nested functions. First thing we want to show is that f squared g is g of f. All right, okay. So let's do both. F squared g of x. Well, that is f squared of 2x. So that is f of 2x. Now, f of 2x is the input plus 1. So that is 2x plus 2. All right, so basically, just a reminder what the function does is it tells me what to do with my input. So g of x tells me to double it. So the x gets doubled. F tells me to take the input and add 1. So f of 2x is 2x plus 1. And then I do f again, where I add another 1 to my input to get 2x plus 2. G of f of x is g of x plus 1, because f of x is x plus 1. We take our input, we add 1. And g of x plus 1, g tells me to take my input and double it to get 2x plus 2. Nice. Nice. Okay, we are going to keep erasing as we go to keep up with a little bit of space. So check 1, done. Let's give ourselves a nice satisfactory kuskadoosh. Right, part 2. We know that g of f squared of g is 4x plus 4. Sure, I mean, I'll take that. G f squared of g of x is 4x plus 4. Can I do that in any other way? Now, we will have seen, right, the point is a lot of these questions that I've been doing, part A influences part B, part C, part D. They do not exist in isolation. So what I can do is I can go, well, f squared g is gf, right? So that tells me that g squared of f of x is also 4x plus 4. Okay. But I could also, if I go back to this thing, gf squared is gffg of x. And I've just said that gf is in fact f squared g. Right? So that tells me that f squared g f g of x is 4x plus 4. Now, what else can I do with that? Gf here is f squared g. And that will give me f squared f to the 4, g squared of x is 4x. This is quite fun. I enjoy doing this. This is quite cool. And that might be it, you know. Are there any gf's I can do? Any more f squared g's I can play with? That might be it. That might be it. But that's quite fun. So this is the sort of atmosphere we're going for here, the sort of vibe where we can start breaking down these combinations of functions and seeing how they combine together. Do let me know in the comment, did I miss one? I have no idea. I think I got them, but if I missed one, put it in the comments for me. Oh no, should I have written all of that down? It's going to come back to haunt me in a second. I'm going to have to go watch my own video. Right, now we're on to an actual result that I don't have. So f to the I, g f to the j, g, f to the k of x equals. Well, one thing to note is f to the k of x is equal to, so every time I do f, I add 1. So if I do it k times, I've added on k. So let's do it step by step. So g of f to the k of x is twice that. That's 2x plus 2k. All right, done. We're up to here. fj of all of that, I'm now going to take this input and I'm going to apply f another j times. So I need to add in j. And then I need to do a g of that. G of that doubles it, which is 4x plus 4k plus 2j. And then finally, I do my last set of f's to it. I do another if's, which adds in another I. Okay? So this is it. And let's write that up here. 4x plus 4k plus 2j plus I. Cool, we had two g's, which means we've doubled twice, quadruple, and then a bunch of adding, doubling, adding, doubling, adding. Cool. Very nice. So how many different ways can I get 4x plus 4m? Okay, so let's find out. Now we can only do g twice. We can only do g twice. So basically what we're saying, if I want to get 4x plus 4m, every time I do g, I double the input, I double the x. So I already know the most I can do is g twice. Funnily enough, the previous part is going to help us. So I can only do g twice, because otherwise I will get 8x if I do g more times. And then any number of f's either side of those. So I'm giving myself the option of every number of them. So essentially what we're saying is this. Okay, 4x plus 4m. Now, m is an integer. We're going to assume m is an integer, just double checking my question there. So 4m is 4 k plus 2j plus I. Now, it might help us a little bit to rearrange it this way, but what we can see here is k can be anywhere between m and 0, right? K can be anywhere between m and 0, right? I could take k as 0, in which case I need to do 2j plus I is equal to 4m. Fine, I'm with you there. And if k is m, I would just have I and j as 0. So that is the biggest k could be, that is the smallest. Right. So let's see what that leaves for 2j plus I, right? What does that leave for 2j plus I? So if I bring the k over to the left-hand side, let's look at j. Now once I've chosen k, what's the smallest that j can be? Well, the smallest j can be is 0, right? Once I've chosen k, this number is fixed. I know m, I know k. So I've chosen k, this number is fixed. The smallest j can be a 0, in which case I would have to be 4 times m minus k. So that's the next thing to realize is as soon as I've picked j, I know I. If I pick j, I know I. I don't have any options left for I once I've picked j. Okay? I can pick a k, I can pick a j, but I can't pick an I. And what is the largest j can be? The largest j can be is if I is 0, and at that point that is 2 times m minus k. So what do we have? Well, we're going to add up this number of options. So for every value of k, from 0 to m, there are 2 times m minus k plus 1 options for j. That is plus 1 because you've got the 0. 0 is an option. So there are 2 times m minus k plus 1 options for j. And there's no options for I. Once I've picked j, I've picked I. So there are this many options for j across this many options for k. So I need to figure out what this is. Now, there are 2 sums that interest me here. Actually, I'll put them here. I've got the sum. I'm going to take out the one that has nothing to do with k, which is 2m plus 1. That's a sum. Minus the sum k is 0 to m of k. All right. So that's just constant. 2m plus 1 is constant, and I've got m plus 1 of them. I've got m plus 1, 2m plus 1s. Now the sum of the integers from 0 to m is m plus 1 over 2. And do you know what? Looking at this, let's give ourselves a little bit more space up here. Let's give ourselves a little bit more space up here. So the number of ways I can do this is m plus 1, 2m plus 1, minus 1/2 m plus 1. Let's factorize out an m plus 1, which leaves me with two m plus 1 minus, let's take out a 2 actually. Let's take out the half as well. Avoid playing with fractions. 4m plus 4 minus m minus 1. Missed out a 2. Missed out a 2 here. That wasn't doing what I did. How many people spotted that and already put it in the chat for me? So I'm going to pull that 2 out front, 2 there. So that half doesn't exist. There we go. Much better. Much better. Is that better? So that is 2m plus 1 minus m, and that is m plus 1 squared. So there are m plus 1 squareds ways for me to pick the I, j, and k to get that function to do that thing. I knew there was a little fiddly guy missing out there. So this does require some summation and knowing how to add up the first k integers. That's a good one for us to know. Do you enjoy this? Let us know. Like I say, if I missed something, if you did spot that mistake, let us know in the comments. It's all good fun. Subscribe, like, hit the notifications. That's the other one. Also, if you want to do more prep like this, practice your big brain power, and get souped up for those A-levels that you may not be taking, check the link in the description to take you to all the details for our A-level maths and A-level further maths courses that we are running. In the meantime, I'm Nick. Whether you look at that or not, I'll be here in a couple of days with more fun videos for you. See you then.